lesson 7.2. We are now in quadrilaterals. The first kind of quadrilateral we're going to look like is the parallelogram. So the parallelogram is a quadrilateral where both pairs of opposite sides are parallel. That is the definition of parallelogram, which we could use in a proof. We have a little symbol for a parallelogram. Not only is it a long word to write, it's annoying. So we could just use the little symbol instead of writing out the word. But also, just like with triangles, we put the symbol out in front of it to denote that that shape we are talking about is in fact a parallelogram. So this would be read as parallelogram PQRS. So if we are given that this figure here is a parallelogram, what are some things we can tell about it? So we know we are starting with some parallel lines here. So if I had this line and this line are parallel and I drew a transversal, then these angles would be supplementary because they're consecutive interior. Same as if I had drawn this parallel line and this one, this angle and this angle would be supplementary because those are consecutive interior as well. So we know that the consecutive angles, as we're going to call them, are supplementary. Something else we know is with our parallel lines, if I drew this transversal here, with the top and bottom being parallel, these would be alternate interior angles. And with these two sides being parallel, these would be alternate interior angles. Knowing that, I could say that AC is congruent to itself as well by the reflexive property, so these two triangles are congruent by ASA. And once we know the triangles are congruent by ASA, we can say any of their corresponding parts are also congruent. Like this side here is the same as this side here, and this one here is the same as this one here. So these are the opposite sides that are the same. And our last angles would match, the ones that are opposite each other. If I had drawn my diagonal this way instead of having angle B and D, I would have had angle A and C match. So that's three properties so far. The opposite sides are congruent in a parallelogram. The opposite angles are congruent in a parallelogram. And the consecutive angles are supplementary in a parallelogram. If I drew both diagonals at the same time, I can also show, knowing now that the opposite sides are congruent, that these two triangles are similar by ASA, which means that this piece here and this piece here would match by CPCTC, and this piece here and this piece here would match by CPCTC. So the diagonals are what we're going to call the two lines that are crossing here, the diagonals, when they connect from one vertex to a non-consecutive vertex. They bisect each other, right? E is the midpoint of BD because it split it in half, and E is the midpoint of AC because it split it in half. So the diagonals bisect each other in a parallelogram. So let's find the indicated measures here. I want to know AD. AD is opposite BC, so they're the same. That's 8. DC is opposite AB. They're the same. That's 15. The measure of angle A is going to be supplementary to its consecutive angle. So 180 minus 68 is 112 degrees. And then angle B is opposite angle D, so they're the same. So that is 68 degrees. Example 2, we have a little bit more information now. VS. VS is part of the diagonal. It's the same as UV, so that would be 7. RV. So they gave us down here, I know it's not on the picture, but RT, this whole segment is 30, making each one 15 because it was bisected. So RV is 15. UT is opposite RS, so that's 27. And then US, if that was 7 and that was 7 together, US would be 14. Another example, now we're going to focus on angles. So I have y's that I could solve for. I know they're part of the diagonal, so they're equal. So 2y minus 5 equals y plus 4. So y equals 9. I have an x here. It's opposite this side, so those would be equal. So 5x would equal 27. X would equal 5.4, I want to say. Let's double check. That is correct. And then for our final one, 3z is down here. It's not this whole angle, so it's not going to be equal to this whole angle up here, but I do have parallel lines, so I could use alternate interior angles. These would be the same. So we could say that 3z equals 33 and z equals 11. So here's a problem for you to try. You could pause now if you'd like. Answers are posted online. We want to determine the coordinates of the intersection of the diagonals of parallelogram FGHJ if these are our coordinates. So I'm going to do a little rough sketch, FGHJ. The way I labeled this, it might not match where it would have been exactly on the graph, but when you are naming a parallelogram, once you start going either clockwise or counterclockwise, you can't jump around. So if I started here and went F to G, I can't jump down here to H. I have to continue on to H, then J. So I do know the diagonals of this picture would be FH and they would be GJ. So if I want to know the intersection of those, I want to know what is the ordered pair where they meet. If they bisect each other, they have the same midpoint. So if I find the midpoint of FH and I find the midpoint of GJ and they match, then that is the ordered pair. That is the intersection of those diagonals. So remember the midpoint formula is the average of the x's, comma, the average of the y's. So if we're going to find the midpoint of FH, oh, I wrote the H first, that doesn't matter, negative 2 plus 2 over 2, 4 plus negative 3 over 2, so that's 0 over 2, which is 0, and 1 over 2, which is 1/2. So now we'll do the midpoint of GJ. So that's 3 plus negative 3 over 2, and 5 plus negative 4 over 2. So 0 over 2 is 0, and 1 over 2 is 1/2. These do in fact match, so the intersection of those lines would be 0, 1/2. I would not rely on just doing one and hoping for the best. It's very easy to make a silly mistake by finding the wrong segments or something like that, so make sure you do find both to verify that that is in fact your correct point. Here's try 4. You could pause if you'd like. The answers are posted online. For example 5, this is very important to know how to do because if you choose a project that I assign, one of the choices you do have to create a figure that is a type of parallelogram, and this is how you would do it. Any 3 points to start with. It didn't matter what the 3 points were. Here I'm starting with -1, -3, -3, +2, and 4, -4. And I'm going to label them. Okay. We know it's supposed to be WXYZ as the parallelogram. It tells me its name here. So that means W connects to X connects to Y connects to Z, and Z connects back to W. So this is two sides right now of our parallelogram. This side here should have a matching parallel and congruent side here. So if I counted the boxes, down 1, 1, 2, 3, 4, 5 to the right, I should match it from this point, down 1, 1, 2, 3, 4, 5 to the right. So that means Y's coordinates are 2, 1. All right, and that's how you can create a parallelogram. Knowing any 3 original points, we could find the 4th point that will make it work. So here is one for you to try. You could pause, check your answers online. And of course, we wouldn't complete a lesson without a proof. So here we are given that we have 2 parallelograms. We're given parallelogram LENS and parallelogram NGTH. So if I start with parallelogram LENS, we know that angle E is supplementary to angle ENS, this angle here and this angle here, because the consecutive angles are supplementary in a parallelogram. So the properties that we learned before, we could use them exactly as they appear in our proofs. So now I'm talking about the two angles I just called supplementary, their measures adding to 180. We know whenever we see a word and now we're describing what happened with that word, it is the definition. So definition of supplementary. Now we have angle ENS. Angle ENS is here and it is congruent to angle GNH, which is here. These are vertical angles, so we're going to call that the vertical angle theorem. Now I have angle GNH, this one here that I've already marked, congruent to angle T. So these two angles are congruent because they're opposite each other in the parallelogram. So opposite angles congruent in parallelogram. So now I can connect. I've seen ENS before right here. I've seen GNH before right here. Sorry, T. And they were both congruent to GNH. So I'm linking them together using the transitive property. Remember, that cannot be substitution because we were using a congruent sign, and substitution never ever works with a congruent sign. Now I'm changing them from congruent to equal, so that's the definition of congruence. And I've seen a statement before that equaled 180. Back up here, step 3. They both started with measure of angle E, but now instead of angle ENS, I have angle T. I've replaced it because it was equal, so that we will call substitution. And now that I'm saying that these two angles add to 180, I can call them supplementary by the definition of supplementary. This is the last problem for you to try. I would recommend you do. Answers are posted online for you to check, but that is the end of section 7.2.